Welcome to the first video in the series on fractions. It will cover the basics. In the fraction 2/9, 2 is the numerator and 9 is the denominator. A fraction is used to describe part of a whole. 1/4 means 1/4 of a whole. You see, the circle is divided into 4 pieces. The shaded part represents 1/4 of the whole circle. If you had the fraction 2/4, it would represent 2/4 of the whole circle. That is 2 sections of a circle divided into 4 equal sections. As you can see from this example, 2/4 is the same thing as 1/2. But we'll get more to that later. Now, this video series is designed to teach you how to add, subtract, multiply, and divide fractions, and help you do that more effectively. There's a few vocabulary terms that we'll need to learn. To simplify fractions, we can factor the numerator and denominator. In the statement, 3 times 5 equals 15. 3, 5, and 15 are factors, and 15 is called the product. And using the dot's just another way to indicate multiplication. To factor 15 means to write it as a product. The number 15 can be written as 3 times 5 and also as 1 times 15. A fraction is said to be simplified or written in lowest terms when the numerator and denominator have no factors in common other than 1. For example, the fraction 5/11 is already in lowest terms because there's no common factors other than 1. To help us simplify fractions, we write the numerator and denominator as products of prime numbers. A prime number is a natural number other than 1 whose only factors are 1 and itself. The first few prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and the list goes on and on. It's a good idea to memorize this list, at least this far. It'll help you in the long run. A natural number other than 1 that's not a prime number is called a composite number. Every composite number can be written as a product of prime numbers. We call this product of prime numbers the prime factorization of the composite number. For example, we'll write 40 as a product of primes. First, we'll write 40 as the product of any 2 whole numbers other than 1. So here we have 40 equals 4 times 10. And now we'll factor each of these numbers. Now if we break down 4, we have 2 times 2. 2 is a prime number. And break it down 10, we have 2 times 5. And 2 and 5 are both prime numbers. So the factors of 40 are 2 times 2 times 2 times 5. For another example, we'll use 63. Now, what times what equals 63? 9 times 7 is 63. Now we'll break down the 9 and the 7 into primes. 3 times 3 equals 9, and 7's already a prime number, so we stop there. And the prime factorization of 63 is 3 times 3 times 7, because 3 times 3 equals 9, and 9 times 7 equals 63. Now, to use prime factors to write a fraction in lowest terms, we'll apply the fundamental principles of fractions. Now, the fundamental principle of fractions states if a over b is a fraction and c is a non-zero real number, then a times c over b times c equals a over b. To understand why this is true, we use the fact that since c is a non-zero, then c over c equals 1. Now a times c over b times c equals a over b times 1, and that just equals a over b. Taking the fact that any number multiplied by 1 equals itself, we call this process dividing out the common factor of c. To practice, let's write some fractions in lowest terms. First, we'll go with 42 over 49. So first step is to write the numerator and denominator as products of primes. And now we'll factor out the primes, and we're left with 2 times 3 equals 6 over 7. So 42 over 49 in its lowest terms is 6 over 7. Now let's do another one. 11 over 27. Now we know 11 is a prime and 27 equals 3 times 3 times 3. But there's no common primes to factor out, so 11 27ths is already in lowest terms. In this lesson, we've learned prime factorization, how to write fractions in simplest form. We've learned what the prime numbers are, and we've learned the fundamental principles of fractions. In our next lesson, we'll learn multiplication of fractions. That's it for today's lesson. Go ahead and subscribe and hit that notification bell so you'll be notified when the next video is available. Thank you for watching, and until next time, go figure.